Okay, so this is the Unit 9 first lesson. This is hopefully going to work this time. I don't know why I couldn't get audio to you. I'm sorry it's taken so long to get these notes to you. We are talking confidence intervals again, so we're taking a pause on the hypothesis testing from the last unit. And so now we're going to be finding confidence intervals. The formula for the confidence interval is always identical, no matter what type of confidence interval you are creating. You always take your point estimate and you add and subtract your margin of error. So a point estimate is what we use for our statistics. So if I'm estimating a population proportion, that statistic is going to be, I said proportion, the sample proportion. But here we are now estimating means. So if I would like to know what the population mean is, I'm going to use a sample mean. So the statistic is X bar. Critical value, we're still going to be using that Z star ideally. And we talked way back when we were actually still in school. If you remember the time I had you all go up and put X bars on the board, we talked about the sampling distribution of sample means. The formula for the standard deviation changed. It became less variable when you took samples that weren't size 1 anymore. And we had said that it was changing by taking your original population standard deviation and dividing by the square root of your sample size. That was our standard error of the statistic. That would all be well and good and we would move on if it wasn't for the fact that if you don't know mu, you're not gonna probably know sigma either, because sigma uses mu, and if you don't know mu, you can't even calculate sigma. So that's a problem in this formula. You're missing a big chunk of it. So just like we use X bar as our point estimate of mu, we can use S sub X as an estimate of sigma. However, there's going to be some problems that are created. So we are going to look at an applet, which I'm just not realizing I don't think I have open yet. We're going to look at an applet for simulating what happens if you use one or the other. So I would have had you do this in class. Yep, it's not even open. I apologize. The first time I made this video, it was ready, but of course not this time. Sorry. So I'm going to open it up. I don't want to have a proportion interval. I'm going for the mean. We're just going to keep the first option as normal, and we're just showing the first part where we're going to find you're going to use Z for your critical value, and we're using sigma. Now, the problem that I already breezed past, but are still in the notes if you're looking at that, it's talking about a farmer who's estimating mean weights of all her tomatoes, and it says at the end, suppose the population mean is actually 100 grams, and the population standard deviation is 20 grams. The farmer isn't going to look at all of her tomato plants. She's going to take samples of size 4 and then calculate an interval based off of that. So we're going to be looking at creating a 99% confidence interval, which remember is our capture rate if we repeat this many, many, many times. So if I just hit sample, my first sample captured the population mean. So this is my statistic value here in the middle, and then we add and subtract a margin of error. So if I just keep repeating this lots and lots and lots and lots and lots of times, it'll be red if it ever misses. And I'm not missing any yet. At the bottom left of the screen, you can see the running total. I have now sampled over 100 of these confidence intervals. Every single one of them has captured the mean, which kind of makes sense. I'm supposed to be having a 99% capture rate, so it should happen a lot of the time. This is a bit abnormal to get this many. Okay, seriously, I'm trying to find one that doesn't. Oh, there was one. So the moment I got one that didn't capture, you can see it drops my capture rate, my running total to 99.6. It's supposed to be mimicking a confidence level of 99% though. So that's what would happen if you know sigma. But like I said, you are not likely to know sigma. So let's just see what happens if I keep using our regular critical value Z, but now I use whatever my sample of size 4, whatever its standard deviation is, we're going to use it to create our confidence interval. So if I reset this, still looking for a capture rate of 99%. If I hit sample, my first one captures it, second one, Oop, there's the first one. I already got one that didn't. I do this a couple times. There's another one. There's another one. There's another. There's 2 more, 3 more. So it's a whole lot more common for me to not actually capture my population mean. So I have a 91% capture rate here. So rather than doing this individually, I could do this a lot quicker. I'm going to change it to getting 20 intervals at a time so that we can see what would happen. So if I did 500 of these confidence intervals, this is showing a capture rate of 93%. So no matter what, even if I do this lots and lots and lots of times, I'm not getting the capture rate that I want. When I repeat this over and over again, it's not coming close to the 99% that we're supposed to be getting. And what you end up seeing, this is a good illustration of it, the ones that are not capturing it, it's a really short little interval. This one is just too short. This one's too short. Like it's just not quite long enough to capture what we want. So there's another option on this one. There's a different type of critical value that we can use. So if I sample this, so here's just a sample of 20, you'll notice that all of these happen to capture it. So I'm just going to repeat this a bunch of times, just like before. So some of them are still not going to capture it because I don't want all of them to. I want a 99% confidence level. I would like that capture rate. But what we're seeing here is by changing this to T instead of Z, changing that critical value, we get the capture rate we're supposed to be getting. We can end up making these intervals crazy long. Some of them are still short. Sampling variability exists, but most of these are insanely long, and so that's how we can get our 99% confidence capture rate. Sorry. So that's all that we just went through on your notes. So that's what we're talking about when we talk about a T critical value. It changes your multiplier so that you can actually get the capture rate that you're wanting to have. When we do this, it changes your formula. When you put S up here, your sample standard deviation, and then you change it to a T-star critical value, that is no longer the same type of interval. What we're going to call this one is a one sample, because we're just going to base our estimate off of one sample's data. It's called a T interval now. All the ones prior to this were Z intervals. And I'm going to state what it is that I'm trying to estimate. So it's a interval for a population mean. So I'm going to get into the T-star values in a little bit, how to calculate them, but I'm going to try and cut this video short because I think that might have been some of the problems